Service Logic, we believe the future of the skilled trades lies in training and development, and that's why we created the Edge, a platform dedicated to empowering our greatest assets, our people. From hands-on training to leadership development, Edge is where technicians grow their skills, expand their opportunities, and build lasting careers. Because when people succeed, our companies, our customers, and our industry thrive. This is the Edge. This is the future of the skilled trades.
I chose iConnect training equipment because I already previously had some iConnect training equipment. And I was very pleased with the equipment I had, the quality of it, and pre-designed labs that came with it. So when I expanded it more into the catalog, I decided I wanted to get this refrigeration trainer in my program to expand my program. My experience so far using the TU-155 has been a pretty good experience, especially my second year students. And it the light bulb kind of syndrome goes off when you see that little flicker in their eye and oh, I got it. That's what us instructors, what we look for is the I got it moment. And this helps me to the I got it moment with my students, and that's what's my goal to achieve.
We are Daikin, the #1 global indoor comfort provider. Our innovative home and building solutions are engineered with energy efficiency and sustainability at their core, ensuring improved indoor air quality for all. From heating and cooling to ventilation, air purification, refrigeration technologies, and connected devices, we're at the forefront of technology, addressing the pressing challenges of sustainability.
Hello, everyone. Thank you so much for joining us once again on Did You Know, the ESCO HVAC show. If you remember, about a year ago, I took a trip down to Florida. I was invited to go down to the Danfoss Turbo Core facility, and I was just blown away. It was a newly opened facility, and it was not at all what I expected to find in a manufacturing atmosphere. Honestly, it was clean as most cafeterias you would ever go into on the manufacturing floors. Quite the spectacle. But it's been a little while, and we've seen a lot of changes happening in the industry, and we often get the question, well, what is a magnetic bearing compressor? Like, what's the applications? Is that something we're going to see everywhere? Well, when we think about our systems, our HVAC and refrigeration systems, as we continue looking for higher efficiency equipment, we have to be thinking about what ways can we improve upon the things that we already know. And that's really what we're starting to focus on when we look at things like magnetic bearing compressors. We're looking at where are those potential places to reduce friction. We can reduce friction, we can reduce heat, wear, current. There's a lot of things that we can change. So today, Jason Nollman is joining us from Danfoss. How's it going?
Great. Thanks for having me. I'm here. Excited to talk about HVAC and turbo core compressors.
And it's very intriguing what is happening in that side of the industry. Hey, Jason, where are you joining us from today?
Yep. So I sit in Columbus, Ohio. So it's
really?
Some nice spring, warm weather here for the moment, but it's the Midwest, so you never know what's going to happen next.
Yeah, absolutely. I didn't realize you were that close. I'm over here just outside of Indianapolis, Indiana. Todd's joining us from sunny California.
Yes, I am.
Well, let's start talking about like the reason. We've seen changes in compressors. We've went from reciprocating compressors that have crankshafts and connecting rods and pistons and rings that are constantly moving inside of a cylinder that create a lot of friction. We've moved into things like scroll compressors where we're changing the centrifugals so that we have less mechanical moving parts, less friction. We've seen things like rotary compressors, where we're using that same centralized design as a scroll. We're just using a different style pump. Same philosophy. We're trying to reduce friction. And then when we start talking about things like magnetic bearings, like compressors that don't have bearings at all, we go, okay, that's a change. That's not something we're used to seeing. And we get a lot of educators that will ask us, well, how are they made? Like, what's happening inside of those? And so we're going to do that today. We're going to spend a little bit of time. If anyone has any questions along the way, hop in and let us know. That is such a good question. And that's why we're having these conversations. And I'm going to presume, Agus, hope I'm pronouncing that right. If not, let me know. The lubrication isn't there. And that's the exciting thing about this, and understanding how we are accomplishing that. So I think you'll be intrigued by this conversation. So definitely hang in, and you'll appreciate some of this. All right. So just go ahead and give us an introduction and kind of talk about, like, where did it all begin? Why did we go oil free?
Yeah, so if we start at the very beginning of TurboCore, it's actually been a long history. So TurboCore was formed in actually Melbourne, Australia, by a group of international designers and engineers that were not even in the HVAC industry. They came from outside, and they got together to develop a compressor that they wanted to go as variable speed, direct drive, fully integrated electronics, no oil, of course, size of a matchbox, cost $1, and be 100% efficient.
Well,
So
that sounds pretty dreamy right there. I'd invest in that
they didn't get
company.
all of those, but they got some of them.
Sounds like a unicorn to me.
Yeah, exactly. So they started in Australia 30 years ago. They moved to Montreal in 1999 to be closer to the U.S. chiller market, which at that point was by far the largest chiller market in the world. U.S. and North America and China are now neck and neck on the largest chiller market. And then if you fast forward a few years, in 2004, Danfoss bought in to be a 50-50 joint venture with TurboCore. And then also part of that was moving the headquarters from Montreal down to Tallahassee, Florida, where it still resides today.
Okay.
And, one of the reasons for Tallahassee was that Tallahassee was at that point, and still is, the magnetic research capital of the world, with a high magnetic field laboratory that's was the largest then and still is the largest today. There's several research institutions that are located in Tallahassee, Florida, and then also several universities as well.
Yeah, that was intriguing. When I was there at the factory, they had mentioned the facility, and I thought, man, I got to go check this out. It's a massive facility. I mean, we have professionals from all over the world going there to do research and studies. And I would have had to make an appointment. I couldn't just walk in. I was like, oh man, I'd love to check this out. So some other time I'll have to come back and make an appointment and go, at least part of that lab. They have some areas that are accessible to the general public through tours, and then most of the area is not.
Yep. And it's a pretty cool facility. I've gone on the tour a couple times. It's crazy to see some of these. They have the smaller bays, of course, but then they have these very large bays where they're doing all this research and exploring and developing new technologies that maybe they don't even know how they're going to be applied yet. But it's pretty cool to see that engineering and innovation and technology driven research in process.
Yeah, you probably don't have a difficult time finding new recruits to work at the facility, especially from the engineering side.
Yeah, that's the nice thing about having some universities with some really strong engineering programs right there in town. We partner with them for internships, and then also try to maintain and retain as many of that for our engineering positions as we continue to grow.
Now, a lot of our educators that are with us, including Todd and myself, one of the things that we're going to ask is, if I'm interested in learning about this, like where's the training besides here on Did You Know, the ESCO HVAC show today? Like what kind of training is offered in the industry? Because this is a completely different technology that most of us are not familiar with at all.
Yeah, for sure. And there's a couple of slides on this that go into more detail later on. But we have online training that's available to anyone to kind of get a feel for turbo core and Danfoss in general. So there's training specific to turbo core, but then Danfoss also has some really good training modules about any kind of component that we offer. Other compressor technologies, heat exchangers, valves, controllers, pressure sensors, temperature sensors, the full gambit that Danfoss can supply. But specific to turbo core, we have some online training modules that are actually a prerequisite for our in-person service training classes, where service techs can take the class. It's a full 2-day class down at our facility, and then you're qualified and approved to be able to work on a turbo core compressor in the field.
Excellent. Hey, all right. Appreciate you joining us from West Palm Beach today.
Yeah, not too far from Eugene.
From Mr. Silverstein, Professor Silverstein. All right. So I guess we can go back into the brief on it.
Yep.
Like tell us a little bit about that.
Yeah, I think left off when Danfoss had acquired 50%. So in 2013, Danfoss acquired 100% of turbo core, which was really important because Danfoss is a privately held company, and the acquisition was a long-term strategic acquisition because turbo core at that point needed funding to continue to innovate. And, we were ahead of our time. The market really wasn't there at that point for oil-free centrifugal compressors with magnetic bearing technology. So Danfoss enabled having a long-term strategic vision to make sure that it could be funded and continue to innovate and progress forward.
Well, Osvaldo, I'm glad that you're joining us. Osvaldo joins us very regularly from Belize, South America, technician that is learning like what is changing in the industry and what are those next technologies to move into, those higher paying careers in our industry. And this is the way that you go. This is the direction that you start moving into, is the products that have specialty training, that are in very advanced systems, that basically has a shortage of qualified technicians. Most of our industry is suffering from that. But when we get into the advanced technologies, even more so. So there's a very high demand opportunity when we're looking at things like the turbo core.
Yep. So this shows kind of the timetable that was just talking to, right? So we just celebrated 30 years of turbo core. So it's a pretty significant milestone and accomplishment for us to be 30 years of a technology and innovation leader in the marketplace. And, of course, we want to continue to push the envelope and the innovation spectrum further as we move forward.
And it's so interesting how many people have never even heard of an oil-free compressor before. And now we're talking 30 years of research, development, and production. And that's why it's so important for us to have these conversations. Is it's not a new technology. It is something that everyone needs to be aware of and understand because of the amount of efficiency that can be gained in products like this.
So if we look just at turbo core's global footprint, we're one of the few oil-free magnetic bearing compressor manufacturers that have truly a global footprint. So Tallahassee, Florida is a full production facility for us with multiple production lines now. It's also our headquarters and R&D center. And then we have in high-end China, we have a full production facility there, as well as engineering support. And then service centers in both of those. And then also in Denmark, Nordberg, which is also Danfoss Group global headquarters. We have a service center and then what we call a configuration center there, where we can support all three regions in the globe. And then the big thing for us, right? We talked about that 30 years. So 30 years of technology and innovation and pushing the boundaries. But what comes also with that is we have over 180,000 compressors installed in the field. So there's a significant opportunity to be able to get trained on a turbo core compressor to go out and service that install base. And also, we like to say that brings that many compressors installed in the field is proven reliability out there.
Yeah, and to that point, you say 180,000. That's not 180,000 compressors. That's 180,000 Danfoss turbo compressors.
Yeah.
Yes. Yeah, exactly. Yeah.
I had a friend that's a service technician. He's pretty well retired now. He's actually in California, Todd. And he had specialized in units that used the Danfoss turbo core compressor. And because of that experience, he would actually get called to do service for that particular unit around the world. So he became a turbo core professional technician that was in such high demand. Manufacturers would ship him all around the world just to be able to be in front of a turbo core because of the experience and the lack of properly trained technicians. So it is a massive market. I have seen that, firsthand.
Yeah, and that's why I was so excited to join the show today and talk with you guys, because with this install base plus all the growth that we're seeing from the market, we're seeing growth continually on comfort cooling, but the data centers is just an even more incredible. So there will be even more Danfoss turbo core compressors installed in the field, and we want to make sure that we also have the service network out there and the trained professionals to be able to help support out in the field, especially at these mission critical infrastructure sites.
Yeah, indeed. So I hear opportunity as much as anything.
Opportunity. Yep.
All right. So we're going to play this little video. It's just a few minutes long, and we'll hang back in the background. I'll see if I can bring it up full screen for us, and then we'll see you all here in just a few minutes. Man, I'm kind of missing the place now.
I'm excited for when you come to visit for round two.
I am as well. It is just such an intriguing facility. And let me get past this real quick. And I want to make sure that I get this other input muted. Let me get over there real quick. That should be it, so we don't get any background noise from the other screens. So for anyone that was just watching and was having any questions about that facility, we encourage you to, to ask questions, because there's a lot of differences here. We're talking about a state-of-the-art compressor being made in a state-of-the-art facility. So, like, what's the differences, and what are we doing inside of these things?
Yeah. So what is TurboCore, right? We pride ourselves on being the pioneer, as we talked about, in oil-free magnetic bearing centrifugal compressor technology for HVAC. And the analogy that I've heard, and I think is super fitting, is that TurboCore compressor is more like a computer acting as a compressor than a traditional mechanical compressor.
Okay.
So we're combining mechanical, electrical, and software all together to function as one unit within our compressor. And it's, as you can see here, this is kind of a cut shot, see-through covers here to show the different sections of the compressor. And then at the bottom, right, is our shaft. So it's an oil-free, friction-free magnetic bearing shaft design that allows for no performance degradation over the lifetime of the compressor, because there's no mechanical wear and tear. And then we have, the suction. We have the design is twin impellers. We have power electronics on the top that provides all the juice for the compressor, and then on the control electronics on the side. This is our service side, where it's lower voltage, and these are all the service side that you can pull that cover off, and anything that might need service or changed out in the field is available there.
Okay. So it is a serviceable, rebuildable compressor if need to be repaired in the field.
Yep. And, we monitor more than 50 sensors and inputs, and we're taking calculations on that shaft 8,000 times per second to make sure that when it's levitating, if it's moving in the X, Y, or the Z plane, those magnetic bearings are pulling it back to the center where it needs to be.
Well, how do we do that? Is that's what
done
through electromagnet? Yep. Are you getting ready to ask the same thing, Todd?
Yeah. And it's up to somewhere around an 80 micron clearance.
Wow,
and the shaft is spinning. It depends on the model, but it can be spinning up to 40,000 RPM.
What?
Yeah. So it's and just think, at least what always blows my mind here a little bit is this was developed 30 years ago.
Right.
So far ahead of its time, and Dr. Lin's son, who was one of the core engineers to develop it, is still within Danfoss TurboCore. He's now our VP of technology.
Wow. Okay, so I'm seeing a high performance compressor. It has its own built-in drive, its own sensors. Now, what about like on replacement scenarios? Can a TurboCore only replace a TurboCore, or can it be retrofitted into existing design systems?
Yeah, so in the initial days, we were out there promoting anything we could and swapping out a compressor and putting in a TurboCore. Now, what we like to support is oil-free for oil-free, because one of the challenges if you have a chiller that's out in the field with a traditional oiled compressor, it's hard to get all of the oil completely out of that system.
True.
So if you put a TurboCore in there, oil is going to cause issues. So that's one thing that just to be aware of.
Okay. Yeah. I hadn't even thought about that aspect, but yeah, I mean, it would take months or even years to be able to finally get all of the oil out of every piece of that system. And as it's going through, a rotor that is running at super high speeds, that thick oil is going to drag it down. It's going to get in places it shouldn't. Okay.
Yep.
Now on this slide here, is this the 4 different variants? Is there other variants? Are there smaller for much smaller systems?
Yeah, so these are the 4 main models, and even the first 2 there, what we call the TTS series and the TGS series, they're basically sister compressors. The change is on the refrigerant. So the TTS series is for the traditional R134A, and then its newer lower GWP replacement R513A.
Okay.
TGS series, same compressor, same aero design with for the different models, but it's 1234ZE and 515B. So the lower, the ultra low GWP refrigerants of the future. And the difference in capacity there is based on the refrigerant characteristics, because 1234ZE and 515B are lower density, lower pressure refrigerants than 513A. So you lose a little bit of capacity through the refrigerant characteristics.
Interesting.
And then we have a bunch of different models within that TT series and TGS series that we can customize what we call the aero of the compressor. So the impeller design, the volute design, based on if you want to get higher pressure ratios for, let's say, air-cooled chiller applications, or if you need lower pressure ratios for like a water-cooled application that allows you to get higher capacity from the compressor. So we have customization within that family. And then the TTH and the TGH series are very similar, except for, as you can see on that shaft, the 2 impellers are back to back. With the high lift, we call it, the TTH and TGH, we're going for higher pressure ratios. Sure. So we have an impeller on the suction, and then we have an interstage that goes to the backside where we put another impeller to get that higher lift, that higher pressure ratio.
So it's basically like a dual stage compressor in a way that way.
Yep, kind of, yeah. Absolutely. Yeah, and then the VTX series is one of our newer compressors that it's water cooled only because it's lower pressure ratios, but much larger capacity. I mean, you can see it there from the design where it's a 450 ton nominal compressor, and it's also the only compressor that we currently have that has an external drive. Still a Danfoss drive, but it's external from the other compressors are all have an internal drive.
Well, and it brings up a very interesting point that Osvaldo mentioned a while ago is, what type of a operating envelope do you have for a compressor like this? And it's significantly different than what we're used to with like a single stage or an unloaded compressor, because we're actually introducing that VFD directly into this compressor. So how low and how high can it go? How much control do we have on one of these things?
Yeah, it's full variable speed. So we can unload down to, depending on the compressor model, down to somewhere between 10 and 20% of the compressor full capacity. So some significant unloading, especially when, these are larger capacity models. So sometimes, and historically, we'll see single or maybe 2 compressor chiller designs. But now, especially with these data centers, we're seeing, larger and larger capacity chillers in that. So you're putting multiple compressors on there. So you can really unload very, very low, but then still have the full capacity to ramp up and get that full load.
Very, very. It's interesting build of a compressor, and we're going to continue these innovations going forward. When the core was introduced into the industry, we're talking 30 years ago in the 90s, it probably wasn't as well received as it is in today's, generations of equipment, because it was so advanced at the time. We're just now getting into a lot of this style of control, whereas Danfoss on this turbo cores already had 30 years of production to it. So I can see, and I would imagine they're starting to be adopted a lot more now than they have in the past.
Yep. Yeah, for sure. I mean, because it is like I kind of mentioned, more of a computer. So you're not like a fixed speed compressor. It's more, I say it with air quotes, plug and play, where this, controls are so important because the compressor is gonna protect itself, because we have a levitating shaft.
Mhm.
If it sees disruptions, it's going to start to protect itself. But making how you design that compressor into your whole chiller or your unit system to make sure that you're keeping consistent flow and operating within the map of the compressor is really critical. And that's where we really partner with our OEMs, and we work on design together to make sure that our compressor and their chiller is meeting the performance and the reliability that's required from the market.
I foresee a lot of these in the industry. We've been having this conversation internally here at ESCO, and I know that it is a difficult conversation in some areas to talk about the development of data centers. But we've come to the conclusion that they're here to stay in some form or another. They're not going away, and the technology is what will make it a successful venture, because the demand for technicians. We were talking to the United Association a while back, which is the largest provider of data center technicians, and they were looking at approximately 30,000 technicians over a 5-year period just for data centers. And they're going to be working on this, right? That's why we're trying to help everyone understand that today's technology is not what we grew up on. As educators, we didn't work on this in the field. But going forward, we're going to have to at least prepare the next generation for these technologies. We don't want them to get educated on a reciprocating compressor, go out in the field, get some experience, go, I want to be a data center technician. That's where the money is. And they walk in and go, whoa,
What's that?
I don't even know what,
Not,
like, where's my oil reservoir?
Deer in the headlight, right?
Yep.
Exactly.
Yeah, that's one of the things in our service training and even the prerequisite classes of a lot of the times you're walking up to a chiller and you got your gauges in your hand and you're ready to do some work. But if you're walking up to a turbo core compressor, those gauges aren't going to get you very far, because you're going to need to connect a computer or a laptop into get fault and event logs and see what's going on. So it is like you said, it's a mindset shift of how we're going to service this and how we're going to support it.
But it's important for us to look at this, because even our residential equipment is headed this direction very quickly. We're starting to look at new protocols like the connected commissioning protocol that is starting to take some precedent in the industry and may happen by the end of the year, where we're going to be using all of the pressure transducers and temperature thermistors that are already in the equipment to be able to gather all that data. Then we just have to connect and read it. We think about what happened in the automotive industry. We use this reference all the time, but it is so relevant, right? 1990s, we went from carbureted engines into fuel injection, and we went to variable valve timing, all this automated controls. Well, there's a lot there, but how do you work on it? You plug into it.
OBD2.
Yeah, and you read all of the data off from it. And that's really what we're talking about here. So we're looking at technicians that probably have an interest in technology. They're already a bit of a nerd, like all three of us. And they're looking at the technology going, I want to work on something sophisticated. I love computers. I like to be able to tune my Honda Civic. What can I do with this thing? Well, all the same stuff.
Yeah.
And it's interesting, Clifton, you made a good point, and that's kind of why I asked that question earlier. I know these are certificate compressors, but it's moving its way across the industry to residential, to commercial refrigeration, et cetera. These are centrifugal compressors. I'm well aware of that. But the reason why I asked that question earlier is, how small capacity can we get? Is there plans? I mean, Danfoss on this turbo core has got 30 years of experience, left our competition behind. Are they incorporating this oilless magnetic floating device in other types of compressors?
Yeah, so for right now, this is the product offering we have, but we're definitely exploring, right, the need to go larger, the need to go smaller, right? Where is the market driving? Because the centrifugal compressor, and especially oil-free and magnetic bearing, but centrifugal compressors in general, you're speeding up the refrigerant and you're pushing it through, and that's how you're getting your efficiency versus other compressors where you're having where you're having to compact the refrigerant. So it's a more efficient compressor by the nature of it. So all of these applications that are high energy usage. So, data centers is a perfect example. You can really see the payback and the energy efficiency coming very quickly on these high energy efficiency or high energy usage applications where energy efficiency is critical.
Yeah. We're actually in construction here in Indiana of a data center up in northern Indiana that's scheduled for 2.2 gigawatts of power. Right. When we start thinking about the amount of energy that could be saved going into high efficiency compressors like this, it makes sense. I mean, we're significant investments into the HVAC industry for technology, and we're trying to push everyone forward, helping them understand where we're going, because this is our industry, not the future of our industry. This is our industry, and if we're not training the next generation, or at least exposing them to this technologies, I feel like we're falling short, because they're out there, 180,000 of them.
As of 2025, so, and growing.
And growing.
Yeah, so cool. This is just a quick overview of why TurboCore from a general perspective, and I don't want to spend too much time talking on all of them, but the big benefit, like we were just discussing, is the energy and the part load, but also full load efficiency. So the energy and cost savings over the lifespan of the unit using TurboCore. Because we're oil free, we have no mechanical wear. There's no performance degradation over the lifetime of the compressor or of the lifetime of the chiller. So there's various studies out there that will say when you have an oiled compressor or an oiled chiller or an oiled system, you'll lose around 5% efficiency and performance in 5 to 10 years, and then you'll lose 10% in 10 to 15 years.
Yeah, from where?
So so that's pretty significant over the lifetime, right? As we design these compressors and these chillers are getting designed for these longer lifetimes to be supported and fully serviceable in the field, you want to make sure that you have the performance, especially in applications that are high energy usage. You want to make sure that you're staying very efficient throughout the lifetime.
I hadn't even thought about that. I mean, I guess I already knew it. I just hadn't thought about the life expectancy of that, because when we think about any compressor out there, I mean, wear is inevitable because we have friction components.
Yep.
And all it takes is a little bit of liquid in the wrong places, and there's nothing left because we've removed oil from those friction components. So it changes the way that we look at the life of a compressor when it's completely suspended in air. Well, in vapor.
Yeah.
Hopefully not air.
Yeah.
We've got a problem.
Edit.
Hopefully not air and not liquid. We like vapor.
It is called a vapor pump for a reason.
Love it.
And then the nice thing about TurboCore is that the sound level is so low. Really, the only noise that you're going to hear when you're near a TurboCore compressor is the flow of the refrigerant through the compressor, not the compressor itself. And then if you're talking air-cooled chillers or something like that, the fans and everything else are going to be much louder. Sure. There's an example that we've heard multiple times from different people and different customers and service techs of going to an installation site, and it's their first time being around a TurboCore chiller. And, maybe 10 or 20 feet away is the chiller, and the service guys and our team and our OEM are talking, and someone's like, well, when are we going to fire this thing up so we can start seeing what it's doing? And we're like,
already running.
It's already running. It's been running the whole time. And they're like, no way.
And to that point, so it's pretty audibly noticeable as far as you can hear the refrigerant flow because the compressor is so quiet.
Well, and it's just, that's the noise that's really coming out of it is just refrigerant. Amazing. It's not any component or electronics or mechanical on the compressor itself.
So it's basically the mass flow rate of the refrigerant you would hear anything.
Yeah, it's the flow being sped up, and then when it's hitting the discharge and going through the piping, right? That's
Right.
what's going to
Right.
create the noise.
That's
I
what I
hadn't thought
meant.
about
Yeah,
that
exactly.
either. I mean, I've been around turbo cores, but they've always been in mechanical rooms that had other compressors, just general mechanical rooms.
Mm.
I'm looking for one now.
As have I, Clifton. And so that was kind of, unique to me. I'm like, what? You don't hear it.
Yeah.
Because any turbo core I've ever been in any mechanical room, it's got other compressors in it,
Other
right?
chillers, other things going on. Pumps,
Next time you come down to Tallahassee, we can show you. Of course, we have chillers outside, air-cooled chillers that have our compressor, but then we also have some heat recovery units inside to go towards our carbon neutral status for our plant that have turbo core in a mechanical room with nothing else in there, and you can see how quiet it is on a water-cooled chiller.
Intriguing.
That's impressive.
Yeah, absolutely. Very, very cool. All right, let's keep on rolling. Any questions along the way? Anybody out there have anything that they would like to learn more about these different stages as we're moving along? Because I know for most of us, it's a relatively new concept. And we'll give it a minute. If somebody does, we'll bring it up.
I'll pop it in if it shows up. But I haven't. It's been kind of quiet.
Yeah, it has.
So just a couple examples, and they're on Danfoss's website of various applications that turbo core has been used in. So an all-stick hotel that's in Denmark to help get to the Danish carbon neutral targets that they have in that. Of course, data centers would be one example there in the middle, and then also some sector coupling and then heat pumps that utilize turbo core compressors at a hospital in Denmark.
Oh,
so
I'd be interested in that.
Everyone thinks the data centers nowadays, but our business really came from the comfort cooling side. And up until a couple of years ago, most of our business was with comfort cooling. And like I mentioned, we're still growing on the comfort cooling side. It's just the data center demand is so high that now more of our business has shifted to the data center side. But we want to continue to, of course, support comfort cooling and innovate and data centers. But we're also working on new product developments that'll look into heat pump applications and refrigeration as you see more and more electrification of heating and decarbonization become, I think, the next push over the next couple of years.
Yeah,
for sure in Europe, but I think in the US as well.
And all with turbo core technology.
Correct. Yep. Of course, Danfoss has lots of other compressor technologies, but within turbo core, we're looking to develop new variants or even new compressor models that allow us to push the temperatures up higher to go after some of these heat pump applications with higher pressure ratios, higher temperatures, and that to really innovate and try to now push the oil-free technology in centrifugals into those markets.
And that's kind of my question. What my question was earlier is, what else can this be used for? So very interesting. I'd like to know more about that heat pump technology.
Yeah, that's we got a couple things in the works right now. Can't share it all yet, but hopefully soon we'll be able to go out there and really promote it to the market. We just released, or I guess maybe displayed at Mostra in Italy a couple months ago, our first natural refrigerant compressor. So that will use isobutane. And of course, that's the big push for Europe is this natural refrigerants and isobutane. Yeah. I think there's some challenges short term to apply that in the US, but we do see the push to natural refrigerants, and we want to make sure that we're looking and exploring all the different avenues and applications and what that means for our compressor.
I mean, I know Europe has different charge
levels. Yeah.
Oh yeah.
But what would the charge level be on something like that for isobutane?
Yeah, in Europe, they don't have the charge limits like they do in the US. That's where I was saying short term, I don't know how applicable it is in the US. But it is, we are exploring outside of, our traditional scope of comfort cooling and the refrigerants that we know and seeing how can we incorporate natural refrigerants, right? How do we look to push the technology and innovate for the future?
Yeah.
I am so glad that you mentioned that, because I could have had this entire show just on this topic, because I have a significant part of our industry that says that I'm crazy that we're bringing R290 in for residential air to water monoblock systems. And I'm telling you that we're just years away from that because of the applications that are already successful. Because exactly what you're talking about a isobutane, a R600A on the isobutane side, that is a chiller outside running on a centrifugal oil-free compressor. All the refrigerants outside, we're just piping water or glycol out to it. There's no reason we can't use that A3 highly flammable refrigerant outside, away from everything.
It's interesting you mentioned that, Clifton. How many of us have barbecues outside of on our patio?
Yeah. How many pounds have we got of that A3 sitting outside?
Yeah. I think I have 2 tanks sitting outside right now. One is a backup. So
everybody's so scared of it, but yet it's there already.
Well, that's really, really exciting to know. I'm actually working on some R290 chiller equipment and technologies that are coming to the industry, particularly from other countries, but all of our manufacturers are waiting to bring those into the United States because of the success of them. And this is a perfect example of that. So I may have to reach out and learn a little bit more about the European versions of these things.
Yeah, for sure. I mean, this is where Danfoss, being a global company, is helpful. So we have presence in all the regions globally, and maybe one region wants to develop something first, but then you can look at, okay, can you get the performance needed, and then how do you implement that and take that to either the same or a different application in another region, and push the boundaries of technology.
Yeah, because now we're talking about a low to medium pressure refrigerant that's got a fantastic heat transfer capability. Put that into a frictionless compressor, get the RPMs up on that thing. There's a lot of potential on that.
Yeah, it's a great refrigerant. You just got to get over the flammability part. So
you bet. Yeah, that's the
from
stumbling
the fire
block
code perspective
here in the United States that we've been in. Well, since 1990s, when we should have went to R32, but we weren't ready for an A2L either. All right.
Topic.
Yeah, whole nother topic. Another show. Staying on this slide, or moving
transition
forward?
From natural refrigerants, maybe just real quickly on why turbo core for data centers. And I won't go into all the details, but I think there's 4 main pillars that we see. And one is really key for the conversation here. So the performance, you can have variable speeds, so you can get load matching especially in these AI data centers where they're changing constantly. We can load match that with the compressor and the chiller. Absolutely. We have the reliability, like we talked about, the proven reliability, 180,000 compressors in the field, sustainability because they're repairable and serviceable. And that's where the maintenance and the service is, right? So it's fully serviceable for the most part in the field. There's only 2 maintenance items that are actually required on the lifespan of the compressor, but everything else is field serviceable. And then beyond that, we have some internal housing ones. And I think we have a slide maybe coming up that'll show what has to come back to us for we can repair, but then send it back out to the field.
Sure. Very, very cool.
And Paul brought up a question there. Can it be, basically a retro? And we answered that already. We can't do that because we can't ever get all the oil out of the system, Paul.
Exactly. So new systems alone.
Yeah, and we see some companies out there that that you're changing out all the piping and the condensers and the evaporators and that, but that depending on the scope of the project determines how feasible it is.
Sure. Absolutely.
A good question, nonetheless.
Yeah. No,
it is.
Indeed.
Yeah. Unfortunately, oil, the one oil free, the one downfall to that is oil is bad for the compressor.
Go figure, right?
We don't want to add friction to a frictionless component.
Yeah. And just to touch here, I think it's really important for us that we have select OEMs that we've partnered with. And this is because applying turbo core to get the performance and reliability like we touched on is so critical for us to be highly integrated with our OEM partner. And then that extends beyond that to the service level. And this is where making sure that we can help train up the next generation of service techs to know how to operate on and service our compressor in the field is something that's really, really important for us. And why I was so excited to join the show today.
Yeah, no, it's very cool. I hope that some of the educators that are joining us are thinking about some of these additional career paths that we can provide for our students. Hope we're thinking about education for ourselves to be able to dive deeper into the new technologies, and for those that are coming back later and watching the show after it's live, to be thinking about the future of the industry and what type of careers are available for us. I always like to look at the transitional careers, those from IT that might be losing their jobs from the advancement of AI, but are mechanically inclined. They don't look at our industry as being an intelligent, computer intelligent industry. But when you see technologies like this, it makes you completely rethink, what HVAC and refrigeration is. We are a very advanced technology and career path. We just have to show it like we are doing right now. So I really appreciate you being here with us.
And to that point, Clifton, as far as bringing it into the classroom, of course, I know, Jason, you mentioned about as far as coming down to the training center. Is there any online applications that for TurboCore, at least to get a teaser to the classroom that other instructors can bring in?
Yep. You're one slide ahead of me. I like the foreshadowing.
Oh, look at that.
I'm just laying the pathway for you.
Yeah. And Todd doesn't even have the slides. I've got
great.
them.
Good job, and we'll go so real quick. This just kind of shows everything in green is field serviceable. The red, which is basically all the internal stuff, the proprietary stuff, that's serviceable. It just has to come back to a Danfoss repair facility. And then, like I mentioned, there's only two required maintenance items: the soft start fan every 5 years, and the capacitors every 10 years.
Wow!
But this is where it's also a good opportunity to make sure that we have the support out there, because there's a lot of compressors being installed. So, in 5 and 10 years, there's a lot of work to go out there and make sure that, not just doing the regular maintenance checks on the chiller, but then making sure that the maintenance checks are being done on the compressor, and these two items are followed as well.
Interesting.
Wow. Yeah. And at 320 pounds on that TGS 380. I mean, that's the physical weight of that thing. Like, I don't need a 5-ton cherry picker.
No.
I've got an 8D that we're going to tear apart in a class sometime in the near future, and it's on the ground right now. And I was looking at it, thinking, well, I wonder exactly what it is. What kind of table do I need? Yeah, something to hold about 1,300 pounds.
Yeah.
So, yeah, big difference. Now, look at there, Todd.
Yep, there you go. There. So we have online learning that you can go to the site as listed there. And there's I think if you go to the next slide, it'll go deep or a little bit further. Yep, there we go. So there's these 13 classes that are free. Anyone can take them online. These are specific to TurboCore. They are a prerequisite if you sign up for our in-person service training, but anyone can go on if they're interested to learn more about TurboCore and see if maybe this is the right path for you. You can sign up for these classes and learn a little bit more. I think there's 13 of them. They're like 10 minutes each. So it's super interesting and a way to learn and see if it, maybe piques your interest to then go take it further and do the service training in person.
And what do those classes cost?
The ones online are free.
That's what I was asking.
Perfect.
Yep.
Yeah, there you go.
My point being, there's no excuse.
No.
Yep.
This is a perfect opportunity to dive deeper into a technology. We may have to borrow one of them and put them on a show sometime. That sounds very intriguing.
Yeah.
All right. Fantastic stuff.
Yeah, and then this one is so our instructor-led training. So this is a full 2-day class where you come down to our facility and you learn everything about the compressor. You're tearing it apart. There's a test at the end. But after you take that 2-day class and you pass the test, then you're certified to go out there and work on a TurboCore compressor in the field.
I just watched a social media post came up a couple days ago of a technician and instructor that was not very thrilled about the requirements for technicians to go through this style of training to be able to be qualified to work on something and receive support from the factory. This is why we're not talking about technology that you're used to. We're not talking about something you've experienced out in the field already and that you can figure out on your own as you're going through it. Like, we're talking about advanced technologies that needs manufacturer specific training. And I completely agree with it. And I actually promote it that if you are not properly trained and certified by a manufacturer, you probably shouldn't be working on this thing to begin with. And so I actually promote that you need to be certified to be able to work on something. I mean, this is advanced technology.
Yeah. And historically, we would offer this class once a month down in Tallahassee, but it's become so popular that we're now up to 2 classes per month down in Tallahassee. Really? And through that website, you can find that link. You can find more information and how to sign up and that. But I've gone through it myself. It's pretty cool. I'm a hands-on learner, so getting to get in there and tear apart the compressor is pretty fun.
I love it. There's your opportunity. There's a lot of instructors that like to get in, get dirty, get their hands into things so they can truly figure it out. This is a perfect continuing education class. So I encourage you all to check that out. All right. A little bit more.
Yeah, and then we have some other online material if you're interested. So turbocore.danfoss, you can find out more information about our compressors. There's some videos on the Danfoss Climate Solutions page. LinkedIn, YouTube has all kinds of service videos. And then the Turbo tool is something we really recommend. It's a pretty cool app that you can go and you can scan the compressor. It'll pull up all the recommended spare parts. You can find service videos on specific service parts within that app. It's really all encompassing, and we're continuing to try to invest in it and put even more content in there and make it even easier to use.
Definitely like it.
And this is our TurboCore Cloud Services newer monitoring tool. So we're looking to how do we take all this data that our compressor is providing and do something with it. So this is something that we're looking, and we're partnering with some of the service tech companies to be able to utilize a TurboCore Cloud where it's pulling all the data from the compressor, it's storing it in the cloud. You can view fault and event logs. You can view all the information from the compressor in this new data age world that we're in.
Yeah, I just had this conversation yesterday, finishing up a class for PG&E where we were discussing what does the future of HVAC technicians look like, and cloud services is one of the highest things of interest that we need to be teaching on because of the amount of data that is now being transferred through that and the data that's available from the equipment itself. Right? It's one thing to be able to have a piece of equipment that has data in it. It's the other to have that data already being processed, looked at, and generating back out analytics and data reports and potential things to go look at when you do have problems.
Right. Yep. Predictive, and also helps you with your predictive. Like, hey, there's something possibly coming up.
Yep.
Yeah,
absolutely.
Yeah, and that's the direction we're going, where we're trying to take all this data that we now have, pull it together, start to develop some algorithms to how can we in the future then do predictive maintenance beforehand, because that would be the key to really help support the field.
Exactly, especially on that service.
And then
side.
This is if we look at all of Danfoss, so we've kind of built an ecosystem around our TurboCore compressor, an oil-free ecosystem where we can offer through Danfoss Climate Solutions all the various line components, heat exchangers, everything like that to support not only the performance of our TurboCore compressor, but also the reliability as well, and try to make it easier for everyone out there to make Danfoss a one-stop shop, if I had to do my sales pitch at the end here.
Absolutely. All right. Well, Jason Kollman, I really appreciate you spending time with us today, and appreciate Danfoss allowing you to get out here on social media. And it's starting to be something that manufacturers are more open to, like getting the information out there, helping people understand the transitions that we're going through. And this is exactly what we need. We need manufacturers that are excited about education, excited about getting the information out there, but also in return, expecting you to commit to the proper training and education out of that. So great stuff today. Any questions out in the audience before we wrap things up? We're right at the hour. And Todd, anything that you find that we need to ask about or cover before we hop out of here?
Yeah. Do we want to let Jason give his contact, how to get in touch with him? If you want.
Absolutely, Jason. We know that we got the Danfoss website. Is that the best way to connect with Danfoss?
That is, yep. You can find everything you need there, and then any kind of inquiries and that can be filtered through there. And someone from our team will definitely be reaching out to help support you.
Absolutely. Thank you. Yeah, Lo, you're right. That's why we tried to stay ahead of the curve. We want to make sure that our industry is prepared. We are going through a revolution or an evolution, depending on which way you look at it. But we are moving forward with technologies that are going to require all of us, whether we're in industrial, we're in commercial, we're in refrigeration, we're in residential, we are going to have to learn the controls of variable capacity systems, how they function, and most importantly, how we work on the things.
That's right.
So I'm glad you enjoyed that. All right, everyone. Well, thank you so much for joining us. So look forward to hanging out with you again next week on the show. And here in a few weeks, we're going to be hanging out live at the Skills USA competition down in Atlanta. We're actually going to have the mobile studio right out in the showroom floor at the interactive experience area. So if you're at Skills USA, come on by and see us. We'd love to hang out. We'll have some swag from some of our studio sponsors. Cool. All right. Professor Silverstein, thanks for joining us. All right. Well, everyone have a good evening. We'll see you next week on Did You Know, the ESCO HVAC show. Bye, everybody.